In this video, we are going to look at different types of organic reactions. The first step is we categorize them based on how the bonds are broken in the reaction. So these are very useful in explaining organic reactions later in something what we call mechanism. So a mechanism is a step-by-step, very detailed explanation about what is happening in an organic reaction, including what is attacking an organic molecule to start the reaction, which bond is broken, how is it broken, homolytically or heterolytically. So this is what we are going to talk about on this slide. So fission in organic chemistry means the breaking of a covalent bond. Homolytic fission means even breaking of a covalent bond. Heterolytic fission means uneven breaking of a covalent bond. So the difference is these two words, homolytic or heterolytic. So in a homolytic fission, even breaking of a covalent bond, both the atoms at each end of the bond leave with one electron from the pair that form the covalent bond. For example, chlorine. Chlorine molecule Cl2 consists of two chlorine atoms sharing a covalent bond between them. So one covalent bond is two electrons. So let me show the two crosses to represent the two electrons between them. When homolytic fission of this Cl-Cl bond happens, each chlorine atom will get one electron from the bond. So now each chlorine atom has an unpaired electron. They are free radicals. So homolytic fission will always produce free radicals. Free radicals are species with unpaired electrons. They are very reactive because by gaining just one more electron, they can achieve stable electronic configuration. Now this example that I'm showing you is two same type of atoms sharing the covalent bond. They have the same electronegativity. That is why homolytic fission usually happens on molecules with the same type of atoms. But that doesn't mean that homolytic fission cannot happen on covalent bonds which are shared by two different types of atoms. For example, it can also happen in a hydrocarbon. Or maybe another example, halogenoalkane. So between this carbon and bromine in this halogenoalkane molecule, they share a pair of electrons, covalent bond, two electrons. So when homolytic fission happens, each atom, the carbon and the bromine will also each take one electron because this is called homolytic fission, even breaking of a covalent bond. So again, two free radicals are formed. One is the CH3 free radical, the other one will be the bromine free radical. Now we go to the next type, heterolytic fission. So heterolytic fission means uneven breaking of a covalent bond. So when the breaking is uneven, one of them will take both the electrons, the other one is not taking any of the electrons in the covalent bond. Now here the example is HCl. So between H and Cl, there are two electrons. So a covalent bond always consists of two electrons, right? So when uneven breaking of this bond happens, chlorine as the more electronegative atom will take both the electrons away. So leaving hydrogen without any electron. So in a heterolytic fission, a cation will be formed Other atom which took both the electrons will become an anion. So unlike homolytic fission, now ions are formed. So let's use the same halogenous alkane molecule, CH3Br again. So when heterolytic fission of this CH3Br bromomethane molecule happens, bromine as the more electronegative atom will take both the electrons. So the two electrons, heterolytic fission. So bromine took both the electrons, became the anion with lone pair electrons. So this lone pair was the covalent bond. Carbon didn't take any of the electrons, so it is now having a positive charge. It is electron deficient, that means it didn't achieve stable electronic configuration. It has only 6 electrons around it. So this is not stable, it has a positive charge. Now this type of species is called a carbocation. So a carbocation is when an organic molecule undergoes some bond breaking. A species that is produced has a carbon with a positive charge. So this species is called a carbocation. So this species, because the carbon didn't achieve stable electronic configuration, so it is an electron deficient species. Now here in this line, I wrote that this carbocation is a species called an electrophile. Okay. So in the next slide, we are going to look at what is an electrophile and what is a nucleophile. An electrophile is an acceptor of a pair of electrons, and a nucleophile is a donor of a pair of electrons. So I explain to you using example. In this example that I'm using, a carbocation reacts with a chloride ion to form a chloromethane. So what happened in this example is carbocation has received a pair of electrons from chloride ion. Chloride ion has donated a pair of electrons to the carbon. Then this reaction produces a chloromethane. So the carbocation is the electrophile because it is an acceptor of lone pair electron. The chloride ion is a nucleophile because it is a donor of a pair of electrons. From the word electrophile, we can also see that an electrophile likes electrons and a nucleophile likes nucleus. So what is in the nucleus? Protons are in the nucleus. So an electrophile, because the positive carbon doesn't achieve stable electronic configuration, it likes to accept a pair of electrons. So it is an electrophile. And a chloride ion having lone pair electrons are looking to donate its lone pair electrons, so it is attracted to the positive carbon in this reaction. So it lights the nucleus. So this is another method of identifying an electrophile and nucleophile in a reaction. But if you are asked to explain what's meant by the term electrophile or nucleophile, an electrophile is an acceptor of a pair of electrons, and a nucleophile is a donor of a pair of electrons. So next, we are going to look at a few common types of organic reactions. The first one is addition. Now, how do we recognize a reaction is an addition reaction? When you see two or more reactants form only one product. In this example, I have ethene and chlorine, two reactants. At the end, they are added to each other and only one product is formed. So these kind of reactions are addition reactions. Elimination reaction is always a larger molecule. It's removing a small molecule to form a smaller product. So what kind of smaller molecules they are always removing? Water is one of them. So see, water is small compared to the molecule that we start from the beginning. Now another very small molecule that is always eliminated is HCl. Okay, or methanol. So if you see that we only start with one larger molecule, at the end, okay, there's a small molecule that's being removed, water, HCl, or methanol. So that kind of reaction is called an elimination. Substitution, by looking at the word, something is replaced, something is substituted. So for example, methane, here, one of the hydrogen is replaced by Cl at the end to get a new product. So something has been replaced, something has been substituted. This kind of reaction is called a substitution reaction. We have seen hydrolysis of inorganic compounds in chapter 10, periodicity. So organic molecules reacting with water is also called hydrolysis. The word hydrolysis means breaking down of a molecule by water. So in this example, a halogenous alkane molecule is hydrolyzed by water to form alcohol. Now, reaction with water is often very slow, so we'll usually add acid or alkaline to make the reaction faster, having a higher rate of reaction. We're going to look at oxidation and also reduction of organic molecules. So oxidation in organic reaction is an addition of oxygen atom or removal of hydrogen atom. More common one is addition of oxygen atoms. We'll use oxidizing agents such as KMnO4, potassium dichromate, the acidified type, to oxidize organic molecules. So in writing equation for oxidation in organic reaction, we do not use the oxidizing agent because that would make the balancing very complicated. So we usually use a square bracket O to represent oxygen atoms that we use from the oxidizing agent in the reaction. Now this is an example of ethanol being oxidized to aldehyde. So the other byproduct, water, is missing here. Right, so let me add the H2O. Now let's look at this reaction from ethanol to ethanol and water. only one oxygen atom is used from the oxidizing agent, so the balancing will be one oxygen. So we only have to put one or without putting any number in front of the square bracket oxygen. Reduction in organic reaction means removal of oxygen atom, or the more common one, addition of hydrogen atoms into a molecule. Here, the example ketone, propanol, is being reduced to an alcohol. So from propanol to alcohol, we have added this one hydrogen and another one more to the carbon. So total of two hydrogen atoms are added to propanol to form propan2-ol. So for the balancing, we'll put 2 in front of a square bracket H to represent the number of hydrogen atoms needed or required for this reaction to happen from the reducing agent. So for both oxidation and reduction, we do not need to show the complete formula of the oxidizing or reducing agents. We use only a square bracket oxygen or square bracket hydrogen for the equations. So that will be all the common types of organic reactions.